Welcome to our channel. Today we're diving into the wonders of our very own galaxy, the Milky Way. This celestial structure, a swirling island of stars, gas, and dust, holds our own solar system and billions upon billions of others. From its ancient name to its mysterious formation, here are 21 mind-blowing facts about the Milky Way. Prepare to be amazed. Have you ever wondered how the Milky Way got its name? Long ago, before the invention of telescopes, our ancestors gazed up at the night sky and saw a band of hazy light stretching across the cosmos. This luminous streak, composed of countless stars too faint to be individually discerned, resembled a spilled river of milk. The ancient Greeks, master storytellers that they were, wove a tale around this celestial wonder. They called it Galaxias Kyklos, or Milky Circle, believing it to be the milk spilled by the goddess Hera while nursing the infant Heracles. This celestial river of light, a source of wonder and myth, became known as the Milky Way, a name that echoes through time and connects us to the stargazers of old. Our galaxy is unfathomably vast, a cosmic metropolis teeming with stars, planets, and nebulae. To truly grasp its size, imagine shrinking our sun, a star with a diameter of 865,000 miles, down to the size of a grain of sand. On this scale, the Milky Way would be a sprawling city, spanning a mind-boggling 100,000 light-years across. Even traveling at the speed of light, a mind-bending 186,282 miles per second, it would take you 100,000 years to journey from one end of our galaxy to the other. It's a humbling thought, isn't it? The Milky Way is home to a staggering number of stars, each one a distant sun potentially orbited by its own family of planets. Astronomers estimate that our galaxy harbors between 100 and 400 billion stars. Imagine that for a moment. 400 billion stars, each a pinprick of light in the vast cosmic tapestry. To put that into perspective, if you were to count each star in the Milky Way at a rate of 1 per second, it would take you over 13,000 years to finish. The sheer scale of our galaxy is enough to make one feel incredibly small and yet profoundly connected to the universe around us. Chapter 4. Ancient Light. The Milky Way's birthday. The Milky Way, like all galaxies, is a cosmic elder, its story stretching back billions of years to the early universe. Astronomers estimate that our galaxy formed roughly 13.6 billion years ago, a mere several hundred million years after the Big Bang itself. To put that into perspective, if the entire history of the universe were compressed into a single year, the Milky Way would have formed in early January. The light from some of the oldest stars in our galaxy has been traveling through space for almost the entirety of the universe's existence. When we look at these ancient stars, we are peering back in time, witnessing the universe as it was in its infancy. Chapter 5. A Grand Design, Unraveling the Milky Way's Structure. If we could travel outside our galaxy and view it from afar, we would see a majestic spiral, its arms swirling outwards from a central bulge. This grand design is a common feature of spiral galaxies, and it's no accident. The Milky Way's structure is shaped by the complex interplay of gravity, rotation, and the distribution of matter within it. The Milky Way's spiral arms are not solid structures, but rather regions of higher density where stars, gas, and dust are more tightly packed. These arms are constantly moving, shifting, and interacting with each other over millions of years. Chapter 6. Our Cosmic Address, Pinpointing the Solar System. Within the vast expanse of the Milky Way, our solar system occupies a relatively unremarkable location. We reside in the Orion Arm, a minor spiral arm located about 2/3 of the way out from the galactic center. If the Milky Way were a giant city, our solar system would be located in the suburbs, far from the hustle and bustle of the galactic core. This position, while seemingly insignificant, is actually quite advantageous for life. We are far enough away from the intense radiation and gravitational forces at the galactic center, yet close enough to benefit from the star formation and enrichment of heavy elements that occur in the spiral arms. At the very heart of the Milky Way, hidden from our view by swirling clouds of gas and dust, lies a sleeping giant, a supermassive black hole. This gravitational behemoth, known as Sagittarius A*, is estimated to be over 4 million times more massive than our Sun. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. While invisible to our telescopes, Sagittarius A* exerts a powerful gravitational pull on everything around it, influencing the motion of stars and gas throughout the galaxy. The Milky Way, like everything else in the universe, is in constant motion. Our galaxy is rotating around its center, with stars and gas closer to the center moving faster than those farther out. This differential rotation creates the beautiful spiral structure we observe. Our solar system, along with everything else in the Milky Way, is on a grand cosmic journey, orbiting the galactic center at a speed of approximately 500,000 miles per hour. At this rate, it takes our solar system roughly 230 million years to complete one orbit around the Milky Way, a journey known as a galactic year. The Milky Way is not alone in the vastness of space. Our galaxy is part of a small cluster of galaxies known as the Local Group, a cosmic neighborhood spanning about 10 million light-years across. Within this group, the Milky Way is one of the largest galaxies, along with our spiral neighbor, the Andromeda Galaxy. These two giants dominate the Local Group, their gravitational influence shaping the evolution of smaller dwarf galaxies that orbit them. Over billions of years, galaxies within the Local Group interact, sometimes colliding and merging to form even larger galaxies. Surrounding the visible disk of the Milky Way is a vast spherical halo of stars and dark matter. This halo, which extends far beyond the visible galaxy, is home to some of the oldest stars in the Milky Way, remnants of the galaxy's formation. The halo is also thought to contain vast amounts of dark matter, a mysterious substance that does not interact with light, but exerts a gravitational pull on visible matter. While we cannot directly observe dark matter, its presence is inferred from its gravitational effects on the rotation of galaxies and the motion of stars within them. The spiral arms of the Milky Way are not just beautiful to look at, they are also regions of intense star formation. Within these arms, vast clouds of gas and dust collapse under their own gravity, igniting new stars and creating dazzling nebulae. These spiral arms also act as cosmic highways, funneling gas and dust towards the galactic center, fueling the growth of the supermassive black hole that resides there. As material flows through these arms, it compresses, triggering waves of star formation that propagate through the galaxy. The Milky Way, like all galaxies, formed from the gravitational collapse of vast clouds of gas and dark matter in the early universe. These clouds, seeded with tiny density fluctuations from the Big Bang, slowly coalesced over billions of years. As these clouds collapsed, they began to spin, forming a rotating disk of gas and stars. Over time, smaller galaxies merged with the nascent Milky Way, contributing their stars and gas to the growing galaxy. This process of galactic cannibalism continues to this day as the Milky Way continues to accrete smaller dwarf galaxies. Chapter 13. A Cosmic Destiny. The Milky Way's Future. The Milky Way, like all galaxies, is not a static island in space but rather a dynamic entity, constantly evolving and interacting with its surroundings. In the distant future, billions of years from now, the Milky Way is destined for a dramatic encounter with its closest spiral neighbor, the Andromeda Galaxy. The two galaxies are currently hurtling towards each other at a speed of approximately 70 miles per second. When they collide in about 4 billion years, it will be a spectacular cosmic event, though not as catastrophic as one might imagine. Chapter 14. Stellar Nurseries, the birth of stars in the Milky Way. The Milky Way is a fertile ground for star birth. Within the spiral arms, vast clouds of gas and dust known as molecular clouds provide the raw materials for new stars. These clouds are cold and dense, shielding their interiors from the harsh radiation of nearby stars. Within these cosmic wombs, gravity slowly draws gas and dust together, forming clumps and filaments. As these clumps collapse, they heat up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. And so, a star is born. Chapter 15. The Interstellar Medium, the stuff between the stars. The space between the stars and the Milky Way is not empty, but rather filled with a diffuse mixture of gas and dust known as the interstellar medium. This material, while extremely tenuous, plays a crucial role in the evolution of the galaxy. The interstellar medium is the raw material from which new stars are formed, and it is also enriched with heavy elements forged in the cores of dying stars. As starlight interacts with the interstellar medium, it creates stunning nebulae, illuminating the galaxy with a kaleidoscope of colors. Chapter 16. Galactic Entourage, the Milky Way's satellite galaxies. Like a celestial monarch, the Milky Way is orbited by a retinue of smaller galaxies known as satellite galaxies. These dwarf galaxies, much smaller and less massive than the Milky Way, are gravitationally bound to our galaxy, following it on its journey through space. The Milky Way has at least 50 known satellite galaxies, and astronomers continue to discover more. These dwarf galaxies provide valuable insights into the formation and evolution of galaxies, and they may even hold clues to the nature of dark matter. Chapter 17. The Dark Side of the Milky Way, Unveiling Dark Matter. One of the most enduring mysteries in modern astronomy is the existence of dark matter, a mysterious substance that makes up a significant portion of the mass in the universe. While we cannot directly observe dark matter, its gravitational influence is evident in the rotation of galaxies, including our own. Astronomers estimate that dark matter makes up roughly 85% of the total mass of the Milky Way. The nature of dark matter remains unknown, but its presence has profound implications for our understanding of the universe. Chapter 18. Ancient Relics. The Milky Way's globular clusters. Scattered throughout the halo of the Milky Way are spherical collections of stars known as globular clusters. These clusters, containing hundreds of thousands or even millions of stars, are among the oldest objects in the Milky Way, dating back to the early universe. Globular clusters are thought to have formed in the early universe from giant clouds of gas that collapsed to form stars. Unlike stars in the galactic disk, stars in globular clusters are tightly packed together, giving these clusters their spherical shape. The Milky Way is home to a dazzling variety of stars, each with its own unique properties and life cycle. Stars are classified by their temperature, luminosity, and chemical composition. The most massive stars are hot, blue, and short-lived, while the least massive stars are cool, red, and can live for trillions of years. Our Sun is a relatively average star, classified as a G-type main sequence star. It lies roughly halfway through its 10 billion-year lifespan. In recent decades, astronomers have discovered thousands of planets orbiting other stars in the Milky Way, known as exoplanets. These discoveries have revolutionized our understanding of planetary systems and have fueled the search for life beyond Earth. Exoplanets come in a wide variety of sizes, compositions, and orbital configurations. Some are gas giants larger than Jupiter, while others are rocky worlds similar in size to Earth. The study of exoplanets is a rapidly evolving field with new discoveries being made all the time. While the Milky Way may seem distant and removed from our everyday lives, it actually exerts a subtle but profound influence on Earth. The Milky Way is a source of cosmic rays, high-energy particles that constantly bombard our planet. These cosmic rays can have both beneficial and detrimental effects on life. For example, they can cause mutations in DNA, which can lead to cancer, but they can also trigger lightning strikes, which are essential for nitrogen fixation in the atmosphere. The Milky Way also affects Earth's climate over very long timescales. Thanks for watching. I hope you've gained a newfound appreciation for the Milky Way, our galactic home. It's a place of incredible beauty, mystery, and scientific wonder. If you enjoyed learning about the Milky Way, don't forget to like, subscribe, and hit the bell icon for more amazing content. See you next time.